Welcome back to the trials and tribulations of my 8-bit breadboard computer build. After building part 1 and testing part 1 of the RAM, I went ahead and added the second part and the memory address register as well to the build. Now here you're going to go ahead and see the schematic for the RAM, and part 1 is what's in orange. We've already built that, and part 2 in red is what I went ahead and added to my build. So you can kind of see how everything should be constructed, what chips we're using, and here is also the memory address register schematic. As mentioned, the address lines we were testing is what we're going to be hooking up to that, and here is the area of Ben Eater's final computer that we're going to be focusing on that I just circled around in red. Now here is my breadboard, and the top breadboard is the clock from kit 1. Then we have the second breadboard, which is the memory address register, and then the rest of the RAM. We've added a push button as well, and then at the very bottom we have the instruction register from kit 2. So we have 3 chips that help us when it comes to selecting data that we use for the data lines. Now we're going to go ahead and test out the completed RAM along with the memory address register. So I'm just going to go ahead and hook everything up to power. Now if you're constructing your RAM alongside Ben Eater's testing videos, you will see that we neglected to hook up the select pin for on top of the memory address register up there, so we need to hook up the select pin. You might be able to prevent that if you're following the schematics carefully with the 74LS157 chip. So we want to select whether we're programming or writing data, and pin 1 is the select pin, and it is connected to this red LED up top there for programming, but we need to hook it up to the green LED when we want to go into write mode. So we're going to bring the signal down to where the data lines are and where the dip switch is, so when we switch to write mode, those guys can also be selected. So as you see, I try to push the button, the push button, nothing happens to my RAM, so we need to hook that up. So I went ahead and hooked that up next to my build. I'm just pushing now, testing it out, and you can see now I am able to manipulate the RAM a bit. And I'm going to go ahead and move on to the program counter. I might be having issues with some rewiring, so I'm not done with my RAM just yet, but for right now, we're going to finish this part of the build and just move on to the program counter. Make note of the issues and just keep going. So here's the program counter. We have the registers up top there. And basically with the program counter, we want to go ahead and hook that up to the clock. Now, the program counter counts in binary to keep track of which instruction the computer is currently executing, and it uses the clock cycle for that. So we're hooking up the program counter to the clock, and we just want to go ahead and see if it's going to start counting in binary by using the 74LS161 chip that increments the output on each clock pulse cycle. Okay, so it looks like it's working good now that we know the program counter is working. Next, we're just going to test the results when we change the enable red wire from high to low. Now, the 74LS161 chip has enable pins on both sides that we've connected with that orange wire, and the red wire that we're using is what we use to enable it or not. So when I switch it from high to low, I believe I'm having a circuit issue with the electricity. So you just have to separate the breadboard. Sometimes it's a bit sensitive. So I'm going from high to low to see if I can go ahead and stop that program counter where it's counting if we have to go back and debug a program. So it stopped it. That's great. It's doing what we want it to do, what we're predicting it to do. It's consistent with what we need it to do. So we're going to go ahead and move on to seeing if we can go ahead and display these results onto these yellow LEDs that we've added to the bus transceiver. So as mentioned, we always do the same repetitive testing, just making sure the program counter is working correctly, the power is going, stabilizing through the breadboards. Since I do have the issue with my power adapter, that's just something that I can count on happening and running into frequently. So I just retest it as soon as the power stabilizes over and over again to make sure it's consistent. So I'm able to stop the program counter and let it go. And then now I'm going to go ahead and see it's reflecting onto the bus. So that's good. The only thing I would note is just it's a bit slower than the actual program counter, but it looks like it's mimicking the same data. So that's good. So I think I'm just going to try to get the bus to kind of in sync better with the program counter. So that just might be because of the power, or I might just need to slow down my clock overall. But in the second round of testing with the program counter, we've added this white wire, and that way we can clear the program counter. So that's what we're testing. Here I'm just testing everything right now, making sure the program counter and the bus can link together, and just noticing the little bit of the delay there. And then other than that, with the enable wire that we have in red, so just stopping the program counter from its most recent calculation. And then now I'm going to go ahead and set the white wire to low as well, and that is how we clear the program counter. So we have both those wires set to low, and here's just a close-up of my build. And this is just a final test of my program counter. You can see the bus yellow LEDs are a bit faster, and it seems to be less of a delay with the program counter, so that's good. I'm happy with my program counter. It wasn't too difficult to build. Now with the RAM, I'm still not 100% sure, but technically it's done. Might need some rewiring, or there might be issues with my power adapter. But we're going to move on to kit 4. Thank you so much for watching.